Auzubillahiminash-shaytanir-rajeem. Bismillahir-Rahmanir-Rahim. Dear student, Assalamu alaikum. The topic of today's lecture is sulfur-containing saturated heterocycle Thietane. Thietane is a 4-member sulfur-containing saturated heterocycle. Outline of today's lecture include structure and physical properties of Thietane. We'll discuss about the natural occurrence of 4-member saturated heterocycle Thietane. And we'll discuss about various synthetic methods of Thietane, that how we can synthesize Thietane in the laboratory by various chemical reaction. And at the end, I will discuss about chemical reaction of Thietane molecule. Learning outcome. At the end of this lecture, every student will be able to describe structure, natural occurrence, synthetic methods, and chemical reaction of Thietane and its importance. Structure and physical property of Thietane. Thietane is a saturated 4-membered heterocyclic compound. Its chemical formula consists of 3 carbon atoms, 6 hydrogen atom, and 1 sulfur atom. This is the structure of Thietane molecule. It consists of 3 carbon atom, and as it is saturated, so each carbon atom carrying 2 hydrogen atom. So it consists of 3 carbon atom, 6 hydrogen atom, and 1 sulfur atom. The ring strength of Thietane is slightly greater than that of the 3-membered ring Thyrane, and its dihedral angle is 90. As one can see over here that this angle is 90, this one is also 90, and this one is also 90. It appears as a colorless liquid. It's boiled at around 94 degrees centigrade, and its density is 1 gram per centimeter cube. So its density is approximately equal to the density of water. So this is about the structure and physical property of Thietane. Now I will discuss about the natural occurrence of Thietane molecule. Natural occurrence of Thietane. The Thietane molecule is present in shell oil, and Thietanes are importantly pharmaceutical core or moiety of some biological compound such as Thietane nucleosides and spiroanylated glycothietane nucleoside. This is the structure of nucleosides, which consists of Thyrane molecule. And these nucleosides have thia analogs of antiviral, anti-HIV, oxytocin, and anti-cancer drug toxides, thiathromybuxane. This is the structure of thiathromybuxane, which consists of this Thyrane molecule. Besides pharmaceutical importance, the Thietane is naturally present in certain pesticides. As one can see, the structure of this pesticide, it consists of Thietane molecule. Besides pesticide, it is also present in some sweetener, as it is used as a sweetener, and it consists of a Thietane molecule. And this natural occurrence is reported in the Organic and Biomolecular Chemistry, which is published in 2016, that naturally the Thietane molecule is obtained from the shell oil, as well as it is present in these natural nucleosides and other molecules. Now this is the natural occurrence of Thietane molecule. Next I will discuss about the synthetic method, that how we can synthesize Thietane molecule in the laboratory. So synthesis of Thietane. There are several methods available for the preparation of Thietane molecule. I will discuss here some of them. And the first one by which we can synthesize the Thietane molecule is that we can obtain a Thietane molecule from the hydrolysis of chloromethylthyrane. We can also obtain Thietane molecule from the reaction of Thyrane, simple Thyrane. We can synthesize Thietane molecule from the cyclization of gamma halothioacetate. We can obtain a Thietane molecule from the intermolecular cyclization of 1,3-dihaloalkane. We can also obtain Thietane molecule from the cycloaddition reactions, and this is specifically photochemical reaction 2+2 cycloaddition reaction. And another method is that we can obtain a Thietane molecule from the allyl chloride and thiourea. So I will discuss these methods one by one, starting from hydrolysis of chloromethylthyrane. So hydrolysis of chloromethylthyrane, the 2-chloromethylthyrane can be converted to 3-hydroxythietane on alkaline hydrolysis. This is the reaction. This is the 2-chloromethylthyrane molecule, and when it is treated with a base, one can obtain the hydroxythietane molecule. The mechanism is mentioned over here, that in the first step, base is used as a nucleophile. This base attack on this carbon atom and breaking this carbon and sulfur bond, this sigma electron shift toward the sulfur atom and producing this intermediate species. And in the next step, this sulfur attack on this carbon atom which bearing the halogen and producing the hydroxythietane molecule. So this is the simple method for the synthesis of Thietane molecule, that one can obtain Thietane molecule from the basic hydrolysis of chloromethylthyrane. One can easily obtain the hydroxythietane molecule. Hydrolysis of chloromethylthyrane are reported in various papers, and here I mentioned one of the reference organic and biomolecular chemistry, which was published in 2016, and they use the 2-chloromethylthyrane molecule and treated with variety of nucleophile to produce the Thietane molecule. So Thietane molecule can also be obtained from the reaction of chloroalkyl thyrane molecule with various nucleophile. And the various nucleophile I'll mention over here, that nucleophile may be a carboxylate ion, aryl oxide ion, cyanide, nitride, azide, etc. Even pyridine can be used as a nucleophile in this reaction. In this paper, it is mentioned that various nucleophile can be used to react with the chloroalkyl thyrane molecule to produce the substituted Thietane molecule. So if any one of you are interested to see the various substitution, one can download this paper. This is the DOI of the publication, so one can obtain easily this paper to see the detail of this reaction, that how one can obtain the Thietane molecule from the reaction of chloromethylthyrane with various nucleophile, chloroalkyl thyrane with various nucleophile. So this is one of the method for the synthesis of Thietane molecule. The next method is that we can obtain Thietane molecule from the reaction of simple thyrane, and Thietane can be obtained from the reaction of thyrane with 3-chloroallyl lithium. When this is the methyl thyrane molecule, and when it is treated with the 3-chloroallyl lithium, one can obtain the 2-methyl-4-vinyl Thietane molecule. The mechanism is mentioned over here, that the mechanism is simple, and this 2-methylthyrane react with this 3-chloroallyl lithium to produce these 2-methyl-4-vinyl Thietane. So Thietane can be obtained from the reaction of thyrane with trimethyl oxosulfonium iodide as well, as it is mentioned over here, that this is the substituted thyrane molecule, and when it is treated with trimethyl oxosulfonium iodide in the presence of a strong base sodium hydride, one can obtain the Thietane molecule. And the mechanism is mentioned over here, that in the first step, the trimethyl oxosulfonium iodide is treated with sodium hydride to produce this carbanion molecule, and in this case the hydrogen gas is released as well as sodium iodide is produced, and then this carbanion attack on the thyrane molecule to produce an intermediate species, and in the next step this sulfur attack on this carbon atom which bearing the sulfoxide ion, so it produces the dimethyl sulfoxide ion as well as the Thietane molecule. So in the same paper, this reaction is mentioned that Thietane can be produced from the reaction of Thietane either with 3-chloro-allyl lithium, or the Thietane can be produced by reacting Thietane molecule with trimethyl oxosulfonium iodide. The next method is that we can obtain Thietane molecule from the cyclization of 3-halothioacetate. Commonly, this reaction is proceed in the presence of a base, and generally 2 equivalent of base is used to produce the Thietane molecule from the cyclization of 3-halothioacetate. So this is the 3-halothioacetate, 3-chloropropyl ethane thiate, and when it is treated with 2 equivalent of potassium hydroxide, one can obtain the Thietane molecule, and carboxylic acid is produced as a byproduct and potassium chloride. The mechanism is mentioned over here that in the first step, the hydroxyl ion base is used as a nucleophile. It attack on this carbon atom, the carbonyl carbon, and as carbonyl carbon is electrophilic, so it's attack over here and producing this intermediate species, the pi electron shift towards the oxygen atom. And in the next step, when it comes back, then the sulfur, this sigma electron attack on this carbon atom, releasing the chloride ion. So the chloride ion combined with the base potassium counter ion, producing potassium chloride, and we obtain the Thietane molecule, and carboxylic acid, acetic acid is produced as a byproduct. So this is one of the simple method for the preparation of Thietane in the laboratory, that when the 3-chloropropyl ethane thiate is treated with a base, one can obtain easily the Thietane molecule. The next method is that we can obtain Thietane molecule from the intramolecular cyclization of 1,3-dihaloalkanes. And treatment of 1,3-dihalopropane with sodium sulfide provided Thietane molecule. This is the 1,3-dibromopropane molecule. When it is treated with sodium sulfide, one can easily obtain the Thietane molecule with the release of sodium bromide. So the mechanism is mentioned over here. The sodium sulfide, the sodium carrying plus charge and sodium sulfide carrying negative charge. So in the first step, this sodium sulfide attack on the carbon atom, releasing the bromide ion, which combined with the sodium counter ion, producing the sodium bromide. And as this sulfur attack on this carbon atom, producing this intermediate species. And in the second step, this sulfide ion attack on this carbon atom and releasing the bromide ion. So this bromide ion take this sodium atom and producing the sodium bromide molecule as well as the Thietane molecule. So we can obtain Thietane molecule from the reaction of 1,3-dibromopropane when it is reacted with sodium sulfide. The next method is that we can obtain the Thietane molecule from the cycloaddition reaction. As I mentioned, that it's generally the photochemical reaction. And cycloaddition reaction is the union of 2 pi system to form a ring through acyclic movement of electron. And photochemical 2+2 cycloaddition of thiocarbonyl with alkenes lead access to 4-membered heterocycle. So this is the simple alkene propene molecule, and this is the ethane thiol, the thiocarbonyl compound. And photochemically, it reacts to produce the Thietane molecule. And as it is substituted over here with methyl, and this thiocarbonyl compound is also substituted here with the methyl group. So we can obtain a substituted dimethyl Thietane molecule. And this reaction is also reported in the same publication, which is published in Organic Biomolecular Chemistry in 2016. And in this case, they mentioned that the 2+2 cycloaddition of the thicarbonyl with alkene produce the substituted Thietane molecule. So in this case, they use amine as a catalyst. The next method for the synthesis of Thietane is that Thietane can be obtained from the reaction of allyl chloride with thiourea. So Thietane has also been synthesized by the reaction of allyl chloride and thiourea, And during this reaction, thiourea transfer its sulfur to 1,3-dihalopropane and deliver Thietane molecule. So in this reaction, the allyl chloride is treated with hydrogen bromide in the first step, and then in the next step it is treated with thiourea, and at the end it is worked up with a base to produce a Thietane molecule and producing urea as a byproduct, and chloride combined with the counter ion of the base to produce sodium chloride or potassium chloride depending on the base which are used during the workup process. So this reaction carry in 2-3 different steps, and in the first step the allyl chloride is treated with hydrogen bromide to produce the bromochloropropane molecule, and in the next step this chlorobromopropane molecule is treated with thiourea to produce this intermediate species, as bromide is a good living group. So this thiourea react on this attack on this carbon atom and eliminating the bromide ion, so producing this intermediate species. And in the next step it is work up with a base hydroxide, potassium hydroxide or sodium hydroxide to produce a Thietane molecule as well as the urea molecule with the release of chloride ion, which combine with the sodium or potassium ion to produce sodium chloride or potassium chloride. Next method is, these are all the methods for the synthesis of Thietane molecule, and now I will discuss about the various reaction of Thietane molecule. And Thietane molecule undergo a ring opening reaction with haloalkanes and undergo some oxidation reaction. So as Thietane is strand molecule, so it's undergo ring opening reaction with haloalkane, but it do not react with certain nucleophile. So the first reaction is reaction with nucleophile. It do not react with amines and ammonia. Generally other Thietane molecule react with amine and ammonia and ring opening reaction happen, but Thietane molecule do not react with amine and ammonia to open the ring, but generally it react with haloalkane and the ring opening reaction takes place. And the second type of reaction is that Thietane molecule can easily oxidize in the presence of hydrogen peroxide to produce the sulfone and sulfoxide. So I will discuss first about the ring opening reaction of Thietane. Ring opening of Thietane is common with haloalkane. So when the Thietane is treated with methyl chloride, then the ring opening reaction happen, chloride carrying a negative charge, the methyl carrying positive charge. So the chloride attack on one side. So when the ring opening reaction happen, the sulfide attack on the methyl. So it produces a 3-chloropropyl methyl sulfane molecule. And it's not only restricted to the methyl chloride, it can also react with the iodide, and iodomethane react with the Thietane molecule to produce a 3-iodopropyl methyl sulfane molecule. So both methyl chloride and methyl iodide react with Thietane and the ring opening reaction happen. And be remembered that the Thietane do not open with the other amines or ammonia nucleophile. It's only the reaction take place with the haloalkanes. Next reaction is oxidation of Thietane, and Thietane oxidation takes place in the presence of hydrogen peroxide or peroxy acid and produce the sulfoxide ion and sulfone. When the Thietane molecule is treated with hydrogen peroxide or peroxy acid, it produces the sulfone and sulfoxide ion, and control both the sulfone and sulfoxide ion is produced. So control oxidation of Thietane to sulfoxide is possible. This one sulfoxide is possible using dimethyl dioxirane. So when dimethyl dioxirane is treated with the Thietane molecule, then the Thietane molecule oxidizes to produce the sulfoxide Thietane to sulfoxide molecule, and acetone is produced as a counter ion. So Thietane undergo only two types of reaction: ring opening reaction with the haloalkane and oxidize in the presence of hydrogen peroxide or peroxy acid to produce the sulfoxide and sulfone. In presence of hydrogen peroxide, it produces both sulfoxide and sulfone, while in the presence of dimethyl dioxazine, it produces only the sulfoxide ion. So in today's lecture, I have discussed in detail about the structure of Thietane molecule, natural occurrence of Thietane molecule, as well as how we can synthesize Thietane molecule in the laboratory. And at the end, I have discussed about the chemical reaction of Thietane. That Thietane only undergo two types of reaction: ring opening reaction, and ring opening reaction only take place with haloalkane. It do not react with other nucleophiles such as amine and ammonia, and it oxidizes in the presence of hydrogen peroxide to produce the sulfone and sulfoxide ion. Here are some reference books for further study. Thank you.